Hello Mamma Mia, and welcome to this new video. Go ahead and prove the formula that you have on the board by applying Millman theorem. VA is equal to what you have on the board. So we discovered that from Millman, the voltage at point A, let's say we can have here a point, let's say a small a, here B, and here C. We discovered that the current flowing through the resistor R1 will be going up, this one here and that one there. Let's say this current here is I1 and this other one I2 and here I3. We discovered that the current I1 is equal to the voltage at the higher potential minus the voltage at the lower potential. Here is VA and here V big A, and here is V small b, and here V big A, and that will give out the direction of this voltage, as well as this one VC and here VA. And we discovered that the current I1 is equal to V at the higher potential minus V at the lower potential, which is here VA, all over R1 as well as I2 and I3. So by applying the first law of Kirchhoff, we discovered that we can apply the first law of Kirchhoff. We said that I1 plus I2 plus I3 will be equal to 0. When we have set it like this, let me send down so that I will get a small area. We discover that from there, we discover that I1 is equal to VA minus V big A all over R1 plus V small b minus VA on R2 plus V C minus VA on R3. Knowing that here VA is the voltage at point A, which is equal to E1 depending to the reference of the voltage here, which is M, and VB is E2 which is equal to V2 according to the reference of the voltage M, knowing that the voltage at point M is equal to 0, as well as VC is equal to I3. So by applying it like that, let us go down and replace all the atoms V small a, V small b, and V small a by their respective value. We are going to have E1 minus VA on R1 plus E2 minus VA on R2 plus E3 minus VA on R3. Don't forget that it will be equal to 0 as well. Here is equal to 0. Knowing that, we discover that we have the common terms here, which is VA, VA, and VA here. So we can expand it and put it in the same factor, in the same area. So here we are going to have, let me change the color of the pen. We are going to have E1 on R1 plus minus VA on R1 plus E2 on R2 minus VA on R2 plus E3 on R3 minus VA on R3, all equal to 0. So we discover that we have a common term here, VA. We have a common terms here, VA, and here there. We can put it in bracket and get something very different. Let's say, let me put VA minus VA in bracket open. Here he will remain 1 on R1 plus 1 on R2 plus 1 on R3. All will be equal to, let me take E1 on R2 in the other hand, as well as E2 on R2 in the other hand, and E3 and R3 on the other hand. That will give me negative E1 on R1 minus E2 on R2 minus E3 on R3. Okay, let me send down so that I will get a small area. So when we reach here now, we discover that we can factorize the term negative in this area because we have minus minus minus, we can put the minus before. We can put the minus before and open the bracket, and this one will transform into positive positive and bracket close. Once you have a minus here, now we discover that here you have also the terms minus. We can cancel now. You can cancel now this term by this other one. Then he will remain VA. Then he will remain VA bracket 1 on R1 plus 1 on R2 plus will be equal to E1 on R1 plus E2 on R2 plus E3 on R3. So when we reach here now, what we are looking for now is VA. Is what we are looking for. We can keep VA in one side and divided all the term by these other terms. So you will have that VA will be equal to all this element here up there divided by all this other element. Let me send it down so that we have a small area. So when we reach here now, you discover that we will have E1 on R1 plus E2 on R2 plus E3 on R3, all divided by 1 on R1 plus 1 on R2 plus 1 on R3, and the formula has been proved. That is how you can prove the formula of Millman in order to get the voltage at a certain point. So if you have a question, don't forget to ask in the description section below. I will be very happy to answer that question for you. And if you are new in this channel, don't forget to subscribe to the channel so that you will not lose a incoming video. Switching graph for watching, and don't forget to subscribe. Peace.